Loft features create solid geometry by transitioning from one profile to another. Any number of profiles can be used and can vary in shape and size. Lofts can also incorporate guide curves, centerline curves, and start and end conditions to create the shape required. In this lesson, I'll demonstrate creating loft features for the geometry of this heat shield. Along the way, I'll discuss the options in the Loft Property Manager and some best practices for working with the Loft command. Loft features require multiple profiles to generate the lofted geometry. Lofted profiles can be defined in a 2D or 3D sketch, or a face of a model can also be used. Lofts can also take advantage of sketches or edges in a model for use as guide curves, centerline curves, or direction vectors to shape the loft in between the profiles. For the heat shield, I've created several two-dimensional sketches that will be used as profiles and centerline curves for two separate lofted boss features. The Loft command can be found in the Insert, Boss Base drop-down menu, or on the Command Manager Features toolbar. Like other boss features, there is also a lofted cut feature that can be used to remove material from a model. The feature functions and options are the same for both. In the Property Manager, the first selection box is active and ready to accept the profile selections from the model. I'll start by lofting the elliptical profile to the arc profile at the back. When selecting the profiles, it's important to select them near corresponding vertices. The Loft feature creates connector points to map the vertices of the profiles together, and the primary connector points shown in green will be located at the vertices I select closest to. If I were to select vertices on the opposite sides of the profiles, this would incorporate twist into the feature, and in this case, the feature would fail. Connector points can be manually dragged with the left mouse button to reposition them if necessary. Each vertex has a connector point associated with it, and they can be shown or hidden from the right-click menu. The order you select loft profiles is also important. This loft has only 2 profiles, but lofts can use as many intermediate profiles as is necessary to generate the desired shape. Profiles should be selected in the order they will blend together. To the left of the selection box in the Property Manager, there are arrows that can be used to change the order of the profile selections if required. I need to add some additional information to the Loft feature to create the geometry I need. I'll click the heading in the Property Manager for Start and End constraints. To ensure that the curvature of the Loft feature begins and ends normal to the profile sketch planes, I'll select Normal to Profile for both of these options. I can adjust the magnitude of this condition or add a draft angle by using the additional fields. The Apply to All checkbox is referring to all the connector points in the loft. By default, they will all share these same values, but this checkbox can be cleared to apply separate values to each connector point. Next, I'll add in the centerline parameter. Loft centerlines are similar to guide curves, except that a centerline is designed to control the center locations of the profiles, while guide curves should be used for outside edges of a loft. Also, a centerline does not need to intersect the profiles at a vertex, while a guide curve must connect directly with the profiles. I'll choose the arc on the top plane as the centerline for this loft. There are additional options in the centerline parameters to adjust and preview the intermediate sections for the loft. I'll click the eyeglasses button to preview the sections for this loft, and click the arrows to preview each one. SolidWorks creates intermediate sections throughout the Loft feature to create the blend from one profile to the next. I can increase the number of sections to make the Loft feature more precise, or less to make it more relaxed, similar to adding points to a spline. I'll leave the number of sections for this loft near the center of the slider, and will click the green check to complete the Loft command. The other Loft feature for the heat shield will transition from the rectangular profile to the arc at the back of the part. I'll activate the Loft command once more and start by selecting the rectangular profile near one of its vertices. I'll rotate the part about the y-axis to better see the back face. I'll be using the face from the first Loft feature as the next profile selection. I still want to make sure I'm selecting the face near the corresponding point to map the profiles together correctly. For the Start constraint, I'll add in the same normal to profile condition as the last Loft feature. For the End constraint, there are some additional options available in the drop-down menu. Since the End profile is associated with solid geometry on the part, I have choices to create tangency or curvature conditions to the faces of the model. For this example, normal to profile is the option I need. I'll choose the group box for centerline parameters next, and choose the arc between the two profiles to control the shape of the Loft feature. Taking a closer look at the Loft preview, I can see the profiles are not mapping together the way I've intended. The problem is that there are a different number of vertices on the rectangular profile than the arc profile. I'll use the right-click menu to Show All Connectors. Because of the differences in the number of vertices, some of the connector points have nowhere definite to map to. One way to deal with this is to manually move the connectors to new locations. I'll use the left mouse button to drag the connector points and manipulate the shape of the Loft. While this method works well for some applications, for the heat shield, I want to ensure the top connector points from the rectangular profile are located at the same location along the arc at the right and left. Manually moving the points may get me close, but I cannot add relations or dimensions to the connectors to ensure exact placement. I'll cancel this Loft feature to demonstrate another technique. In the Feature Manager tree, I've prepared a different profile to use. I'll show Sketch 7 in the graphics area and edit the sketch. This sketch was created by converting the entities from the original arc profile, then using the Split Entities command to split the arc into 3 separate co-radial arcs. Now I have a profile with the same number of vertices as the rectangular profile and can control the split points locations using relations and dimensions in the sketch. I'll exit this sketch and reactivate the Lofted Boss feature. From the graphics area, I'll choose the rectangular profile and the arc profile near relative vertices. In the Property Manager, I'll again add a Start constraint of normal to profile and an End constraint of normal to profile. Under Centerline parameters, I'll choose the arc connecting the two profiles on the top plane. I can see from the preview that using profiles with the same number of vertices allows the system to easily recognize how the shapes should map together. Showing the connector points allows me to verify exactly where each vertex is being mapped to. I'll click the green check to complete the Loft feature and hide Sketch 7.